Hello viewers, and you're watching The Maths Geek. This is my third video and it is the second part of my video on the divisor function. So in this video we are going to obtain a formula for the sum of divisors of a number using the function in the previous video, which was delta of n, or the number of divisors function. So let's dive right into it. Introduction, just as a refresher. Sum of divisors are is the sum of all divisors of a natural number. In the previous video, we showed as follows: number of factors of a number n, which can be represented as a power p times b power q, are belongs to these sets. So therefore, the sum of divisors is basically the sum of all the elements of these sets. So 1 plus, so 1 plus this sum as m goes from 1 to p of a power n. So it's this whole set here. And then it's the sum as k goes from 1 to q of b to the k. So it's the sum of this set. Then we're going to multiply these two sums together. Right. So that is our formula for the sum of divisors of a number. And we're going to simplify it soon. Tackling partial sums using a clever trick. Now the trick which I'm going to demonstrate is used to actually find the formula for a sum of geometric series, which we'll do that later. So for now, let this sum SP be denoted as the sum as m goes from 1 to p of a power m. Next, I'm going to multiply this whole sum by a, so it becomes the sum as m goes from 1 to p of a power m plus 1, which is a squared plus a cube and so on till a power p plus 1, which can be written as a plus a squared dot 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 till a power p plus 1 minus a. So it's our original sum plus this a power p plus 1 term has got added, and we have subtracted the a term. Therefore, we can write SP times A, which is this sum, equals SP, which is our original sum here, plus A to the P plus 1 minus A. Now, bringing SP to the LHS, we get SP times A minus 1 equals A to the P plus 1 minus A. Therefore, SP equals A to the P plus 1 minus A over A minus 1. Summing it up. Similarly, we obtain that b power q plus 1 minus b by b minus 1 equals the sum as k goes from 1 to q of b to the k. Now, remember from the formula shown in the first slide, this is how a sum of divisors function can be represented. Now, this can be factorized as follows. Let this sum equal x, let this equal y, then our sum of divisors function is of the form 1 plus x plus y plus xy, which can be written as 1 plus x times 1 plus y, which is done here. Now, substituting the values of these sums into this shortened formula, we get 1 plus a to the p minus 1 over a minus 1 plus 1 plus b to the q minus 1 minus b over b minus 1 equals the sum of divisors of a number. Now, distributing a plus 1 over here, you can notice that this a cancels out with the negative a, and therefore we obtain that the sum of divisors of a number equals b to the q plus 1 minus 1 over b minus 1 times a to the p plus 1 minus 1 over a minus 1. You can extend this based on number of exponents of your number. Again, this is my proof of the formula, which I think is the most common proof which can be found online as well. Demonstrations to verify our formula. Let n equal 5040, which is 2 power 4 times 3 squared times 5 times 7, also known as 7 factorial. Just a fun fact, 5040 is a highly composite number, which means that it is a composite number whose number of factors are more than any numbers preceding it. So Of all the numbers from 1 to 5040, the number with the greatest number of factors is 5040. This has 60 factors. That's a lot. So the sum of divisors of 540 equals 2 power 4 plus 1 minus 1 over 2 minus 1, which is over 1, so I've just left that aside, times 3 to the 2 plus 1 minus 1 over 3 minus 1 times 5 to the 1 plus 1 minus 1 over 5 minus 1 times 7 to the 1 plus 1 minus 1 over 7 minus 1. Simplifying, we get this is 31 times 26 times 24 times 48 whole over 2 times 4 times 6. Now notice that 2 times 4 times 6 is exactly 48, so the 48 from top and bottom cancel out. Therefore, sum of divisors of 5040 equals 31 times 26 times 24, which is 19,344. And that can be verified online as well. Now, the sum of divisors of a prime number. Let P denote a prime and d sub 1 of P denote the sum of its factors. By definition, the prime numbers have only two factors, 1 and the number itself. Thus, we must have that sum of divisors of P equals P plus 1. In putting A equals P and small p equals 1, we obtain that d sub 1 of P equals P square minus 1 over P minus 1, which is P plus 1 as desired. Hence, we have proved the result that the sum of divisors of a prime is P plus 1 for any prime. Thank you for watching. That's all for today. In the next video, I will be proving Euler's famous zeta identity for the zeta function evaluated at positive even integers. Until then, stay tuned. Thank you. This is Gauransh Kapur from The Maths Geek signing off.